Thanks, Jeremiah. I appreciate it. Now I am here. I'm back. Let's start that all over again. Please tell me in the chat if you can hear me this time. What you didn't hear me say is that it's been a while since I've streamed, and now you can sort of tell if that's the case, that I'm new to this. So I'm going to ask in the chat, just like, can you hear me now? Great. Much appreciated, y'all. So, and good to know some folks are here. So Jeremiah and Josh Finney, thank you so much for joining. All right, let's start that again. It's been a little while since I've been streaming. I'm Josh Justice, for those of you who haven't seen me before or connected here before, aka Coding It Wrong. And as I always say, by the end of the stream, you'll get to decide for yourself whether you think I'm coding it wrong or not. So I thought I'd get on a stream again, and maybe we can make a habit of this if it goes well, if people enjoy it. You know, I'm stuck at home isolating. Love my family, but looking for stuff to do. Hopefully all of you, if you're in a country like the US that's really hard hit by the pandemic right now, hopefully you're isolating too. Please be careful. Please be safe. Take care of yourself. Take care of others. But as we're at home, I thought it'd be good to have something fun to do. I love coding. I love test-driven development in particular. And I think there's a lot we could do with more test-driven development resources out there. And so I thought we'd put something together here. So what we're going to be going through together today is exercism.io, exercism with an E. It is a website for code exercises in lots of languages, 52 languages. So you can see that on here. There's a whole bunch, definitely lots of these that I've never heard of before. And you can use it as a way to learn a language, especially if you like learning by doing. These language tracks will walk you through a number of exercises to try things out. And they do it in a way that fits really well with test-driven development. As you'll see in a minute, they give you the tests, and then you pass the test by writing something in the language. So you can use it as a way to learn a language if you want to get into Rust or Haskell or something like that. Today we're going to do JavaScript, which is familiar to me, but the reason is I'm not mainly focusing on learning a language right now. I'm focusing on just getting practice in the test-driven development flow, as well as kind of explaining it, illustrating it. The last exercise I did this morning preparing for this ran into some tricky things, so that was kind of fun. Hopefully we'll get some challenges together here as well. So if you don't have you can just watch if you like, if this is interesting. If you have an Exercism account, you can check out these exercises in parallel if you want. Watch it later. You could pause the video to do an exercise and then come back and see how I did it after the fact. I'm going to log into my account, and if you're live, you could code along and follow along if you like. So, love interactivity. So, y'all on the chat, feel free to jump in with questions, ideas, pushback, whatever you like. I'm happy to kind of interact here together. All right, cool. So, I've done 4 different exercises so far on the JavaScript track, and if you want to check it out, I'm going to post in the chat my profile there so you can take a look and see the exercises. These are all fairly straightforward, so the code so far is less interesting than the exercise, the process of going through it. So we're going to go through that together. So let's see if I can get back to the JavaScript track. Here we are. I'm using the practice mode, which means that I can pick and choose amongst the exercises as I like. There's a mentored mode where a mentor will walk through things with you actively that you could do, but this works out okay here, I think. All right, let's just take the next exercise easy here, and we'll see how it goes. If it's not interesting enough, we can bump up to a medium exercise next. So gigasecond. Given a moment, determine the moment that would be after a gigasecond has passed. 10 to the 9 seconds. Interesting. Don't mutate. So don't modify. Okay, so there's some setup instructions. One of the nice things about Exercism is that it gets the environment, the language you're in, running locally on your computer, or it requires you to set it up. So you are really writing in Node or Golang or whatever by going through Exercism. So that's kind of nice. I've already pulled down the Exercism command line client, which is used to pull down exercises and submit them. So I can just copy this link here to enter this exercise. All right, it downloads here. I can go to the gigasecond folder and open it up in my editor. And I already know we're going to yarn install using the normal approach to install the project, because each of these exercises is one project. And there's more, or we could read through in more detail. Yeah, it looks like there's not a lot more detail in the exercise. It's just sort of general setup steps, so that's kind of nice actually. So we can just take a look at the spec file, the test here, to see what's going on. One thing you'll notice, well, you'll notice when I run the test here, so let me run that. yarn test watch all is going to keep the test running the way I like to do it with jest. It's going to run through the tests. And what we're going to see in here is we have 1 test failed and 5 skipped. So the first test is run and failed, and all the other tests are skipped. And so this, in a lot of the languages on Exercism, this is the way the tests are set up. And the idea is you get 1 test passing at a time. And this is a really key thing about test-driven development, whether you're writing the test yourself or going through an exercise like this, is that you aren't building everything at once. The idea is to write a test that illustrates one specific part of the code you need and then make it pass. And then after that, you take another, you go to the next test and then make that one pass. And so you're gradually evolving the code to handle all the different scenarios you need. Yes, these tests come automatically with the challenge, and that's the case across all languages in Exercism. Basically, you're given the tests in a given language, and then you write the production code to make them pass. That's the way the Exercism works in general, and I think it's really cool. We can see that the error we're getting here for this first test just says remove this statement and implement this function. And so that just makes it clear to us what we need to do. So we can see that statement in gigasecond.js here. So they've defined for us the file that the production code is going to go into that's being imported and the function, but it's just a placeholder function. So we can remove this commentary code. And I like to remove the error that's thrown in JavaScript so we can see the real failure that's coming out. So I save. Jest is going to rerun my test automatically. And now what I see in here is, so gigasecond tells a gigasecond anniversary since midnight. And so this says the expected date was 2043, etc., 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 but we received undefined. So let's take a look at that test to see what the test actually contains. So this says we've got gigasecond, our function is being called on a new date. So this is, I can never keep JavaScript date constructors in my head, so it looks like here it's using the date.utc function to create a date, and it sure seems like it's passing in year, month, and day. We get the result back, and then we set up another variable, expected date, and so this one is using date.parse so that hours, minutes, and seconds and things like that can be passed in. So then we're doing a check. We're setting an expectation. We check that the result of gigasecond here is the same as expected date. And I just remembered I bought a mouse app. Oh, that's on the other computer. I'll have to install that for next time, a nice mouse app that makes it easier to see my cursor. And so I'm not flailing around like this. So we'll flail for today. All right. So we see this test. Honestly, this is a good one to start with because honestly, dates are pretty intimidating to me. And so this is really going to force me out of my comfort zone, and I'm going to really need to take it a step at a time. So just looking at the names of these tests coming up, test another gigasecond anniversary since midnight, so it's just checking a different date. Testing one from before the Unix epoch. Dates before 1970 in software tend to be handled differently if they're supported at all. Tells the anniversary, including a full-time specified, so I'm looking at the comments here. Full-time specified, full-time with day rollover, does not mutate the input. So there's a bunch of different things happening here. Yeah, honestly, I can't quite process it, even if I wasn't on a stream. So we're just going to get one passing at a time. And so here comes, when it comes to test-driven development, so whether you are writing tests from scratch or working an exercise like this, there's 3 steps in the test-driven development cycle. Red-Green-Refactor. So first, red is to write a test and watch it fail, and we have the test given for us. We have one test now that is failing. Green is the next step, and that means to pass the test. In fact, do the simplest thing possible to pass the test. And that's going to be uncomfortable the way I do that if you haven't done TDD before, and I'll explain why it's a valuable thing to do. And then we'll refactor after that. So we have one test right now, and it is checking a certain expected date to come out the other side. And so what is the simplest thing we can do to get this test to pass, to get it to the received value to be this date? Well, the simplest thing we could do is actually to copy and paste this date in here, and to put it in here, and to return that hard-coded date out of the function. We save it, and the test passes. So that is the simplest way to get to green. And of course, obviously, this is not the production implementation we're going to keep long-term. So why would we take such a small step? The reason why is because we want to make sure that we have tests that are driving us to implement all the functionality that we need, to handle all the kinds of cases that we need. If we just zoomed ahead and implemented what we thought was the final production code, we would not necessarily have test coverage to really thoroughly make sure that it was working. So we want to get enough tests in place that we are required to implement the full functionality that we need. So the next step here is not to say, oh, this is not good, we need a better implementation. The next step is to, well, refactor in a second, and then to write more tests that are going to make us get to that final implementation. And in fact, here we have all those tests. So we're going to let these tests one at a time add more richness to our application, to our implementation. So after we went red and then we went green, so there's the refactor step. There's not much to refactor now. Usually refactoring involves removing duplication. We need to add more functionality, but that's not yet. In the refactoring step right now, there's not much to do. So that step will make more sense if you haven't done it before, once we have more to do in the future. All right, so let's uncomment the next test. We're actually using this xtest function name is what allows you to just put an X on the front of a test to skip it. So we're going to unskip this test and save and let the second test run. So our first test is still passing, and our second test is failing, and it says tells another gigasecond anniversary since midnight. So a different date is passed in than before, and the expected date coming out is also different. And when we check it, we see that it's not correct. We see that we're still getting the same hard-coded date back that we did before. That makes sense because we hard-coded the value. All right, so at this point, oftentimes when you're really doing TDD by the book, you just put in a simple if-else check. And I still don't really know. I don't think we need to do that at this point. I think we can kind of skip past that because we know, I mean, these dates are all changing. We're going to need to handle them. So we need to see what to do to implement this gigasecond, to move forward this amount of time. Checking that README again, they said a gigasecond is 10 to the 9 seconds. So I think what we need to do to get this test to pass, as well as the other one, is we need to actually do some work with the input. We can call it start date. So I don't actually know, like I said, I remember very little about the date APIs in JavaScript or in most languages. So we're going to need to check the docs to find out how to increase this. Really what I'd love to do is just add 10 to the 9 seconds to that date. That may require us getting it into the form of seconds or milliseconds. So let's go through and see what we can do. There is a tab, bookmarks toolbar, yeah, this one, devdocs.io. I love this site for reference because you can just get to all kinds of different languages and libraries all in one place. So let's go to JavaScript date. C, skimming, epoch, timestamp is sometimes the value. So we can pass in the timestamp, but how do we get the timestamp? Let's just Google it. JavaScript date to timestamp. Date.now. Number of milliseconds elapsed since January 1. But I don't want that. I want the timestamp of a specific date. Just looking all over Google here. Date.getTime. Number of milliseconds since the Unix epoch. Okay, great. So date.getTime is going to guess milliseconds. So let's start date.getTime. So this should give us the milliseconds. Let's do milliseconds. So now we want to increase the time by that amount, 10 to the 9 seconds. And so that's going to be, man, yeah. Sometimes I'll probably want to put this in a constant or something like that. But it's going to be this many seconds. And so add 3 more. I don't even know if those 3 zeros. Yeah, there we go. Add 3 more zeros for milliseconds. So this is, I think, 10 to the 12th milliseconds. There's probably a better notation to do that in JavaScript. We want to increment it, and our linter is saying that it's a constant, so I can't reassign to it. So I'm just going to do a let so we can reassign. And so then we need to convert that new time back to a date. And I think if we just pass in a number into there, it'll handle it. So this might work. We convert to a number, increase it, and convert it back to a date. And this might, my theory, I got advice from a guy I used to work with to, when you're not sure what's happening and when you're pairing together, to say what you expect to happen. Because that way you're anticipating it. And so if something different happens, you can compare the expected and actual. So here, I don't know for sure. I would not be surprised if I got the date logic wrong. But I expect that, hopefully, both of these tests will pass because we're correctly adding a gigasecond to these dates. I save, and they both pass. I'm honestly surprised. So that is very good to know. So our test was red, and then we went to green. Now we can think about refactoring. When it comes to refactoring, sometimes you want to wait to see if something really is going to be reused and going to stay constant as you're changing it in the future. And so because we have these tests already ready and we can run them right away, I think I'll hold off for a little bit before I do refactoring. Maybe I'll do refactoring at the end, or maybe after 1 or 2 more tests I'll feel like refactoring. So let's go to the third test. Third test for date only specification of time. Oh, I think that comment is out of date. Oh, maybe it's saying this is a third test that falls into the category of date only specification of time. But then the test name is saying it's from before the Unix epoch, just to make sure that that scenario works correctly as well. It's kind of surprising to have a comment describing a test above the test description. One of the nice things about the spec style test is that you have a string, and so you can put all the detail in there you want. But we're working with the test we have. So we're going to uncomment the third test, save. I will always expect these to fail. Oh, but this one surprisingly did not. So we've already written for our last test a pretty generalized solution, and so this one passes right away. And so that's fine. So we'll just move on from there. We'll test the next one here. So let's see, let's do that thing again where we make a theory of what we expect is going to happen. In this case, the full time is specified on the date. We're checking the input and the output. I expect this will pass right away because I expect that calling getTime on a JavaScript date is in fact going to include the seconds and hours and minutes and everything like that. And so we increase it and convert it back. I think it's going to be correct. So let's see if I'm right. And it passed. So great. The next test here, full time with day rollover. Tells the anniversary is next day when you are born at night. Yeah, it looks like the start date is very close to midnight. Oftentimes with day boundaries is very important to test. I'm not sure why, just given even just the concept of gigaseconds, I'm not sure why this might sometimes fail, depending on the implementation, but it's good to test it to make sure. So I expect that this will pass. And it did. Cool. So check this out. This next test is checking that we don't mutate the input. This is cool. I haven't seen this too often, but in a language like JavaScript where the language can't guarantee that you're not mutating things, this is pretty cool that you can actually specify in a test that the thing is not mutated. I may actually try to see if we can figure out with this the mutating way to make this change. So let's uncomment this and see. I expect that it'll probably succeed. It did. So let's see, just for an experiment, just for learning, let's try the approach that would mutate the date just to compare it. One of the things that I love learning at the consultancy that I work at right now, I've just learned a ton in the last 5 years that I've been here from all my coworkers. And one of the things that I've learned is to dig a little deeper. Like just because you've got something succeeding, go one step further and say, well, what's a different way we could do it? Or, do I really understand why this is working? So that digging deeper can be really good. So let's see if we can get this last test to fail by mutating the input. And notice how they're testing it. They're getting the input, they're calling gigasecond on it, and in this test we're not checking the output. We're checking that the input object is the same as a new one that's created from the scratch that's identical, that it has not been changed. So let's get that last test to fail. So here's our current implementation. And so how would that work? And I think there's a way, the idea here of this test is that there's a way to get all the others to pass, but to have this last test fail because we are mutating it to the right new value. So if we could set the time on a date, that would allow us to do that. So let's see if there's a set time. Yeah, this sets the date object to the time represented by a number of milliseconds since January 1st, 1970. It didn't even occur to me to do this because I've been working in React a good amount lately, and in React, like in a bunch of ecosystems lately, there's a big focus on immutability. Like let's keep things not mutated if we can, because it just increases the predictability of our application. So it's kind of fun interesting that it didn't come to mind. So we can say, also the fact that we're returning a value kind of suggests that you'd be surprised if the value mutated. So we could say start date. Actually, we could keep these lines, but we could say start date set time milliseconds, and then return start date. So my theory here is that we will get the right times back, the right dates back for all of these, but the last test will fail because it's mutated. And sure enough, there we are. Yep, the others pass, but we confirmed that the value, is checking that the input value was unchanged, but it was changed. We did change it. And so now if we return it back to the immutable version, which is actually fewer lines of code, but it is another date object in memory, and it's passing. So cool. So now we've reached the end of our suite, and so now we can do that refactoring that I deferred. It's great in the TDD cycle, or the TDD loop, when you go from red to green to refactor, that you get this regular reminder, if you don't always skip it, a regular reminder to think through your code to see how you can reorganize it. So I have a milliseconds value, and this is called a magic number code smell. There's a number that's in there, it's a constant value without really an explanation of why it's there. And I did sort of explain it in a comment, but that's already indicating, well, wow, it's really hard to read with that many zeros afterwards. So let's first extract this to a constant value and give it a name. I think this will increase the readability of our code for the future. So what are we going to call this value? Gigasecond in milliseconds. So gigasecond is like a unit of time, but milliseconds is the measurement of it. I'm not sure that name is the best, but we'll copy that over there. We'll still copy this because it's hard to see just how many zeros are involved there. And then down here, we're going to use the constant instead. We're going to say milliseconds plus equals gigasecond in milliseconds. Now, as I'm doing refactoring here, I'm expecting the tests are going to continue to pass. So when I save, it passes just fine, and so we're good. The other thing that occurred to me is we do have this value here that is being mutated. It's being, not mutated, but that variable is being overwritten. And so we could not do that. We could just inline this addition up here to be the new millisecond value. Let's make that change and see what we think about it. This is one of the things with these nice small refactorings with a nice test suite to cover it, is that you can make small changes, see what you think, and then keep them or change them back. So now we see the milliseconds value already starts out as the starting time plus the gigasecond. And it can be a constant now because we're not reassigning to it. And then we return a new date that has that number of milliseconds. So let's save, and it still passes. Another thing we can do is rename this to like new milliseconds. Or rather, I said start date, so we could say end milliseconds. That would be another variable name. Now, this is all internal to this function, so it's probably pretty easy to see what's happening in this function just by looking at it. So no big deal. Start date. We could save this variable to an end date variable if we really wanted clarity, if we're really having trouble following that. Yeah. So that gives it a name. You could also inline this right into the date constructor, but there's enough going on there that I think having a variable for it is nice. Having a variable for the end date here I don't think is that necessary. So I think this is how I'll leave it. I'm going to check. I never ever get to use exponential notation in dates in any language, let alone JavaScript. Let's go see if we can find a way to do 10 to the 12th power. I think JavaScript dates do handle, JavaScript numbers do handle that. It's kind of fun that these exercises can lead you to something you wouldn't come across in your normal work that could be useful in the future. 2 exponential. Good old W3 schools. It turns into a string. Yeah, so scientific notation. All right, e to the number. All right, cool. So let's try that out. So I think this is 1e to the 12th. I think that's going to be the same. 1e to the 12th is the same as 1 times 10 to the 12th. Let's see if it works. Yeah, very good. Very good. Very cool. If you wanted to, you could also do gigasecond in seconds. If you need that calculation for somewhere, and then milliseconds is times 1e3. Oop. I had an issue in my comment there. And that works just fine. Since we don't need that, I think that's fine. We're fine without it. Gigasecond in milliseconds already explains to us why it's called that and why it's 12 instead of 9, and we can dig into there if we need to. So I think we're good. This was kind of fun. So let's submit this exercise and then we'll pull another one up. So the way this works, I'm going to have to check back on Exercism to see. So it says solve, use your code editor to solve the problem locally, and then submit. Exercism submit, and then you just pass all the files to submit in. So I think when you haven't, in this case I haven't changed the spec file. I'm not sure if you're supposed to submit it. Sometimes I do make significant changes to the test, and so I'm going to go ahead and submit both. This gigasecond.star, we're going to submit those two files. And this is why the Exercism CLI is there, is because it handles that, it's authenticated. We can go pull up the solution on here. And so now you can see it here. It's all submitted and come up. I'm going to mark the solution as completed. I'm going to publish it and allow others to comment, and so y'all can actually check it out if you want and comment on it. Just to show that, we can view published solution. If we go to, I forget where my profile is. My profile is here. Yeah, so you'll see gigasecond on there. You can check it out if you like. So feel free to do that, live on the stream or later. All right, well, let's really stretch ourselves next, and let's see another exercise that's maybe crazy challenging, at least more challenging. Bob, I think I did this one before. I don't remember it being super challenging. It's pattern recognition. Let's do it. It's the first medium one, so let's pull it down. One of the nice things about practice mode is that we can do them in the order we like. So this says, Bob is a lackadaisical teenager. In conversation, his responses are very limited. He answers sure if you ask a question. He answers whoa, chill out if you yell at him. Okay, so some kind of interactive thing there. And that's about it. And the tests are going to walk us through the details. All right, so we're going to go back out of this directory, paste in the command again to download the Bob exercise for the JavaScript track. We'll pull it up. We're going to need to yarn install, which we can just do with the shortcut Y. And then we have our spec file. Oh, it's installing, and so it'll be able to come when it's installed just fine. That warning will go away. So something to think about here is that the use of tests to specify the behavior that you want. The README is able to be pretty short, although it is kind of describing things in English language to give us the sense of the goal. But it doesn't need to be too very detailed because the test is going to specify what's needed. So this is part of the mentality of test-driven development, is that you specify what your code needs to do first, and then you make it do that thing that you specified. So this is an example of test as communication. You could use it for the initial implementation. You could use it to support re-implementing. You could rip out the implementation of a function or a larger bit of code and start it from scratch. All right, so we've got our Bob exercise. Again, it's just starting with 1 at the start. Ooh, there's a lot going on. Cool. All right, I'm glad this is substantial. In my own apps, I set watch all by default. I know with the Create React app tooling, watch all is the default as well. But since we're just pulling down these exercises, I'm just going to do that by hand. Ooh, that's a lot of examples. We may not get to all of those today. All right, stating something is the first one, so let's take a look at that. First of all, that thrown error is making it a bit harder to see the expected and actual value, so I'm just going to strip that out and save. Now let's see what it says. Expected to get back a whatever. We got undefined. I think this is just sort of the default response. Unless there's something more specific going on, he just responds with whatever. And so since that's the default, it actually kind of makes a bit more sense than last time to just paste in this value. So we have our red test. We want to make it green as the second step in test-driven development. And the easiest way to make it green is to just return this. In fact, it's not even totally clear from the pattern yet, unless you've done this exercise before, what the logic is supposed to be. So maybe that's helpful to actually encourage you to say, hey, just look at one test at a time, gradually go through it. All right, so we've got that test passed. We're green, and I don't know enough about what Bob is going to do to have any ideas how I might refactor this at this point. So we're going to move on to the next test. Uncomment the next test and run it to let it be read. Shouting. And it says that when we shout at him, excuse me, he says, "Whoa, chill out" in advance. All right, so I don't remember exactly what shouting entails, and so this is, I think, a good reason as well to stick with the concrete and make it more general, as further tests are encouraging us to make it more and more general. So we're going to take this watch out value and say, okay, well, I don't know what and all shouting entails, but I know that at least if I say watch out, that is one example of shouting, so we can check for that. So let's say if message equals watch out, return, I forget what he said. Whoa, chill out. All right, we've rerun the test and this passes. So if we say watch out, he says whoa, chill out. Otherwise, he says whatever. All right, let's go on to the next test. You know, I'm going to put these one above the other. I think it would help us to see that. All right, so the third test is shouting gibberish. So this shouting as well should result in whoa, chill out. We run and it fails, as we would have expected. This is now going to the default because it's only the text watch out that we're considering shouting so far. So now we have another test that's driven us to do something more general. So I have a theory on what shouting entails here, and I just made the judgment call when I've done this exercise in the past. But let's check the README to see if it actually says. He answers, "Whoa, chill out" if you yell at him. He retorts, "Calm down, I know what I'm doing" if you yell a question at him. All right, so another test is going to get there. He's going to take us there. But at this point, the difference I'm seeing, like, what is the pattern between this that he's responding whatever to and these two that he's saying whoa, chill out to? And what I see is that it's in uppercase. And so another way to say that is all the letters are in uppercase, which another way to say that is there are no lowercase letters in the string. So if there are no lowercase letters in the string, but I just realized something else. There do have to be letters, but just no lowercase letters. So maybe a good way to say it is if we say we do find at least one uppercase letter and we find 0 lowercase letters. I think that would be a good way to do it. Because, you know, but as far as like what's the simplest implementation that would pass the test though, looking for no lowercase letters would pass the test. So let's stick with that. And if we need to ensure that there are uppercase letters, hopefully there's a test that will drive us there. And if not, maybe we could add it. Maybe that's our interpretation. So regular expressions are something else that I forget how to do in JavaScript. So let's go to dev docs. JavaScript. Regular expression. All right, there's literal notation, so that's nice. And then I think I remember there being a string.match. Matches. So it takes in a regular expression object, and it returns an array if it's found, or null if no matches are found. All right. Is there matches? No. Regular expression match. It's called in string. Yeah. If there was one that returned a Boolean, that would be kind of nice because like that's all the information we need at this point. But I think we can use this one just fine. String.match. All right, so what we're saying is if the message matches, we're saying if there are no lowercase letters, and to do that with a regular expression, you do A to Z in there. This is not taking into account for characters outside of ASCII set that have accent marks, or even basic ASCII or something. So we're not taking into account of accent marks. I do not have a test for that. I do not know how to look into that. So if a test drives me there, I will go there. So, designing your test is important. If you're using this code for production, you're test driving it, and you say, oh, well, I'm just writing this very simply because that's all the tests have driven me to, you do need to know your real business requirements. So my theory is, if I've gotten the regular expression right, I think that this will pass the test. It will match on this string, and so not match. Well, wait. Yeah. If it matches, I might even reverse this. No, yeah. If there are no lowercase letters, we say whoa, chill out. But if there are lowercase letters, we say whatever. So I think this will pass all three of the tests, and it did. So that's great. So we could have checked for the uppercase letters as well, but again, our test did not drive us to that. So we went from red to green. Let's talk about refactoring. Do we want to refactor? You could put this in an else statement, an if-else, but I feel like there might be other conditions because there are multiple types of responses. So I think having a default answer makes sense. So leaving the test in this format to even explain that, I think is valuable. So let's go on from here. Asking a question. I'll come on our next test and run it, assuming that it will be red. And it is. Does the cryogenic chamber make me look fat? The result should be sure. So if we ask a question, we get a sure back. The best way to look for asking a question, I imagine, is look for a question mark. So that seems pretty straightforward to check for that. We could just add an if at the start. I'm going to add it as a standalone if for now. Message. You could pull off the last character, or you could use a regular expression. Just for the sake of doing it differently and looking at the API, let me see how to get that last character. Well, it's a bit harder to express because you're going to need to look up the length of the string as well. So since we're matching on regular expressions, let's go ahead and do that here. I do happen to know my editor doesn't like that as a regular expression. We need to escape the question mark to make sure it's recognized as a question mark. And then the $, I think, is going to be the end of the string. So this is saying check if the message matches a question mark at the end of the string. And if so, we're going to return sure. We run it, and it passes. Cool, so now we have conditions around our multiple different responses. Now, if we find that the other patterns all have regular expressions as well, then maybe we could remove some duplication. But I think it's best to hold off on that refactoring to wait and see. Again, we have these next tests we can get to right away, so let's let them drive us to our implementation before we do this refactoring. All right, asking a numeric question. I should have made a prediction before I saved this. Coming back to this, you're what, like 15 question mark? So the test is saying, hey, even if there's a number in there, it should still succeed. And yeah, we're just checking on the final question mark, and so that's good. I would not have thought of this case, but maybe in a production application, this was a case you wanted to make sure to handle, and so you can add a test for that. And it's not in the normal test-driven development flow to add a test that passes right away, but if it's an important case to cover, you should add a test for it. And not everything has to follow that normal red-green-refactor flow. So this test does in fact pass. Let me make a prediction this next time before I proceed. Test asking gibberish. You should still get sure back. This kind of helps ensure that we're not looking at anything about the words there. We're just simply looking for the question mark at the end. In a sense, you could just be saying that this is defining that there's nothing more specific required than that. So I'm pretty sure that we'll get the response back sure correctly. So we will pass this test will pass right away. And it does. Great. Next we have talking forcefully. Let's go make out behind the gym. We got a whatever back. So it seems like the exclamation mark is not going to cause an exclamation response. So it's interesting. The shouting test here, we might have expected that the exclamation point was what we needed to match on, but then we saw that just having the uppercase letters was enough to be considered shouting. And now having the exclamation point, if it's not in all caps letters, should still give us back a whatever. So I think we will get that because it's not going to match the question mark and it's not going to match the no lowercase letters. And it does pass. All right, moving on. Using acronyms in regular speech. It's okay if you don't want to go to the DMV. So what this is checking, I think, is that having some words that are entirely uppercase isn't considered shouting. And I think, I don't know, maybe I've predicted ahead or thought about it more thoroughly than they were expecting, but this just ensures that those letters don't force it to shouting, and I think this will pass. And it does. All right, forceful question. So this is a question. It's got a question mark at the end, but all the letters are in all caps, so there's no lowercase letters. And we're now getting a different response. Calm down. I know what I'm doing. So I expect this to fail because we're not handling this case, and I expect it's going to catch the question mark case and be a sure coming back. Sure certainly is not maybe an appropriate response to somebody shouting a question at you. So I think we should handle this. So my brain is already going to a super optimized way of handling this, but to follow Red-Green-Refactor the most faithfully and the most academically, you might say, let's just follow the pattern we have and have another if statement. We could add it at the start or at the end. I don't know, maybe at the end is good this time. In this situation, we return, calm down, I know what I'm doing. So what's the condition? Oh, you know what? Actually, being at the end is not going to work because this is going to match a question or a shouting. So we need to check for this more specific case first. So what lets us know that we should be saying, calm down, I know what I'm doing? Well, what it suggests is that it's both of these conditions. So let's copy and paste them to be, in a sense, the most straightforward way to pass the test. We're making sure there's no lowercase letters and making sure it ends with a question mark. All right, so I expect that this is going to pass all the tests, and it does. So we could look at this and say, now the refactor step becomes more interesting because we have implemented this in the most straightforward way that we could, just by copying and pasting that code over, and now we can refactor. There's a few different things that we could refactor. There's some duplication between these matches and then these matches. And also, we're matching against two different regular expressions here, when maybe matching against just one of them would be fine. I have a thought. Let's go ahead and make a decision here because I think we have enough information to make a decision, and then if we regret it later, we can put it back. So I think my mind is more inclined towards removing the duplication of matching these twice. I don't want to create a third regular expression up here. I want to reuse the same booleans that we've checked in these cases before. So let's extract these variables to extract these expressions to variables that we can then reuse. So first we'll pull this one out, and we'll pull it out with the no exclamation point because that's used in both cases. We say is shouting. So that's more of the abstract concept that we're getting at here. Or we could name it something more specific, like what exactly it entails. Let's name it something more specific because we don't know where all this is going to go. So we'll say has no lowercase letters. And so now that we have this variable, we can replace this and this. Although, let's do one at a time. Let's just run this now to make sure it's still passing. It is. Now let's replace this duplicate use of that expression to make sure it's still passing. And it is. Great. So now let's extract an expression, this expression into a variable. So what is this one? Ends with a question mark. So we can now replace this expression, and we can go ahead and do both because I feel pretty confident. So if it has both of these are true, return this. Otherwise, if this one's true, return this. This one's true, return that. This makes me feel like an else-if approach would kind of more directly explain what's going on and kind of make it visible. So let's go ahead and do that. Else if this, else if this, else. That helps me see at a glance. There's 4 alternatives, and all of them are going to return. Nothing's falling through from one to the next. We save it, and it still passes. So that refactoring is good. And I like this refactoring at this point. I think this is good for now, so let's keep moving on. The next test, shouting numbers. Let's just see what happens, and then we'll think through it. So shouting numbers passed. So this is saying 1, 2, 3, go. So if we say 1, 2, 3, go, we get whoa, chill out. And so I think what this is getting at is it's okay for there to be numbers involved. The point is not that it must only be uppercase letters and spaces or something. The point is that there's no lowercase letters. And I think, honestly, from the last time I did this exercise, I had that in the back of my head, and it kind of got me to go there. All right, if it's only numbers, we're going to get whatever as well. I think this will fail. and we'll see why. It does fail. So only numbers is a whatever. So what are we getting back? We're getting whoa, chill out. If it has no lowercase letters, we're getting whoa, chill out. But this is not actually shouting. This is just showing numbers. So now we do need to check something more specific. Now we need to see that the string does have uppercase letters and doesn't have does have uppercase letters and doesn't have lowercase letters. It's not enough to just not have lowercase letters. All right, so let's handle this. And I think following this pattern, we can give another named match expression. I think just following that pattern seems good. So we could say has uppercase letters. Maybe has an uppercase letter. That kind of suggests has at least one. So we say if we are matching A to Z. And I think there are character patterns that we could use, maybe not for just the letters like this, but that's something we can consider in later refactoring. So has an uppercase letter. So what we're saying is that if you have an uppercase letter and have no lowercase letters, that's shouting. But if not both of those are true, then we're going to whatever. So I have a question about whether this condition should be used for the calm down, I know what I'm doing case, but we don't have a test for us to drive us there yet. So if we were writing the test, we could think about that now and decide if we want to add a test. We may add a test at the end of this suite if we don't get there, if we just kind of like that approach, because we're putting this code together the way we like. But for now, let's just see if this passes the test. And it does. All right, so I like this approach already, so I don't think we need to refactor. We don't need to change the function. We don't need to do anything with the current functionality of the code. So let's move on. Question with only numbers. That does work. That is considered a question. And so I think, based on the code, that we're going to get a sure back. So I think this is going to succeed. We save. Oh, and it fails. All right, well, I wasn't thinking about that right. It says, sure, calm down, I know what I'm doing. Oh, great. Okay, so this is exercise, the other case, the question I had about here. So this question with only a number, it has no lowercase letters, and it ends with a question mark. So we got this response as though it was shouting. So in a similar way, just like for this branch, we needed to make sure that there was uppercase letters that entailed shouting, we need to do the same thing up here as well. So we can just bring this up. If we have an uppercase letter and we have no lowercase letters, and it ends with a question mark. So this is the most straightforward way to get this passing, I believe. Let's save it and see that it passes. And it does. So now I'm at the point where has an uppercase letter and has no lowercase letters have gone together twice. So I almost want to combine those into another conditional variable, but I think we should wait a little bit. Again, we have a lot more tests. We'll see if we get there in our exercise today. I'm probably going to end right around the hour, so we'll see. All right, so we're going to uncomment the next test and run it. Shouting with special characters. It passed. Whoa, chill out. Cool. So, and why is that? It was fine that the special characters were in here and numbers. The key was that we had uppercase letters and we had no lowercase letters. So, whoa, chill out is what we got back, and we're good to go. All right, let's move on to the next test. Shouting with no exclamation mark. I think based on our earlier test that this should work as well. So this is not necessarily progressing us. You wouldn't necessarily write it this way when you're writing out a test-driven development exercise. But so I think this will pass right away. Save and it works. So one thing to think about, thinking about implementing this all from scratch. Now, this is a lot of tests to go through. And so if you were to read through all of these tests at once and try to get it all in your head, that would be pretty overwhelming. Or if you just read through the README and said, okay, based on this, I think I know what it means. So I'm going to implement a first shot, and then maybe a smattering of the tests would pass, but a bunch of them would fail. That would probably be pretty frustrating, not that motivating. And so, whether it's writing one test at a time or uncommenting one test at a time, either way, it's letting you step through implementing one case and one bit of the code at a time. Sometimes I will actually write out multiple tests from the start, but only uncomment one at a time myself, because it's just helpful to get those cases out of my mind, but to gradually kind of step into them when I'm doing test-driven development. And just one abstract comment I will make is, I don't do test-driven development all the time, but I do it whenever I have a function that's just operating on just plain JavaScript and it's non-trivial. It's going to be significant. I always test it thoroughly, and very frequently, probably almost always, I test drive it because it's just so easy to write the test first, the expected behavior that I'm trying to do, and then to implement it to make it pass while keeping all the other tests passing as well. And you can see with Jest, it helps so much just to have them automatically run for you. Jest will automatically narrow your test suite down just to the files that are affected by the class that you changed. So there's a lot of intelligence there. I will say we have 7 minutes left. And so, anybody on the chat, if you have thoughts, questions, feedback, different ways that you would approach an exercism exercise or the TDD process, I would love to hear it. Anything you have to chat about. So I will kind of go on and move ahead with this next case, but please chime in the chat if you like. I will stop what I'm doing and respond to it because we'd love to have you involved and kind of talking through it together. So, all right, so for this next test, statement containing a question mark, there's a question mark in the middle, not at the end, and he says whatever. I believe that this will pass given our current implementation's functionality. So this is interesting. Again, when I wrote this, I already looked at the end of the code for the question mark. I did not just say if there's a question mark in it. So I made an assumption there that was what was required, and it was kind of more specific than I needed to be at the time. So let's save this. I believe it will pass. And then after it passes, we're going to try to break it again. I'm going to see if we change this regular expression, if it causes all the other tests to succeed and just this one to fail. And the reason I think it's good to do that, other than just general learning, is then I can see, oh yeah, I can see the case that this test is covering for us and the functionality that it's ensuring is in place. So I expect that when I save this file that this test will pass. It does. So now I expect that if I change this regular expression not to anchor it to the end, but we just say if there is a question mark in the string, I think that will cause this test to fail because this string will be considered a question. And it does fail. Expected whatever, but we got a sure as though it was a question. So we do need this anchor at the end of the string. So this is an example of, again, I sort of jumped ahead and I wrote something that was a bit more complex than was warranted by the test. All right, the next test here, non-letters with a question. Is it still considered a question? I think it will be, although I can't quite think through all the logic unless I walk through it in detail, so let's just see. That is passed, yeah. And let's think about why it passed, because that could be good to really understand your code. So non-letters with a question. It does not have an uppercase letter, so it's not considered shouting. It has no lowercase letters, and it does end with a question mark. So because we're checking for that uppercase letter, it's not going to accidentally consider the shouting, and so we're good. Prattling on. So yeah, so here's like a sequence of short sentences. Exclamation point, period, and question mark. What is it considered? And it looks like the answer is it's responding to the question that's at the end. And I can see that myself doing that. Like, you just said a bunch of stuff I can't follow. The last thing you said was a question, so I'm going to answer it. I expect this will pass. And it passed. Yeah, we're not looking at exclamation points at all. Based on the test we have above, an exclamation point is neither necessary nor sufficient for shouting. Shouting is all uppercase letters and no lowercase letters. Even as I say that, that makes me think, my mind go back to that refactoring I considered earlier, where has an uppercase letter and has no lowercase letters went together. This pattern has continued long enough that I think I'm confident doing a refactoring now to pull out a variable for that. So let's do that. Let's call it is shouting. And this is if we have an uppercase letter and we have no lowercase letters. So you can be shouting a question or shouting a non-question. So let's replace these expressions with a variable that covers them. Now our test passed, and now this is much easier to follow. All right, so I can see, if I'm shouting and it's a question mark, then it's one response. Otherwise, if it's just a question mark, it's this. Or if it's just shouting, it's this. Otherwise, it's whatever. So abstracting out this variable has made our production code read a bit more simply as far as what it's doing. And so I think that's a good refactoring that helps. So what's the response to silence? If we pass in an empty, I zoomed ahead and I cheated to see what else is coming. If we pass in the empty string, we get fine be that way. And so for what we know from this test, empty string is what silence is. So let's uncomment it and see it fail. We never respond with that response. And so let's just handle this. I think we could put it at the top or at the end of the list. I think because these are kind of related, maybe I'll put it at the top of the list. And I'm just going to put the match inline for now. The message is the empty string. We're going to return, fine, be that way. I think this will pass it. It works. All right, I zoomed ahead again. Prolonged silence is next, so I think this will fail because spaces should also be considered silence as well. And so now we can match this a bit differently. We could do this with a regular expression again. Space star. The star means 0 or more instances. Oh, and let's do start and end. So the whole string is 0 or more spaces. So that should match the empty string as well as the string with a number of spaces. I suppose we could have done an or, check for this string or check for this string, but I think this is reasonable to do at this point. We save and it passes. Cool, so I see we have more to go. I'll probably finish this up off the stream just so I can submit this exercise and have it be up there. But yeah, let's think about briefly before we sign off what we've learned about test-driven development. So we walked through these tests, and Exercism guided us by, in JavaScript at least, because Jest easily supports skipping tests. It starts out with just one test uncommented, and we can one test uncommented, and then we can uncomment the others one at a time. And so by doing so, we were able to go through a test-driven development process, just like if we had written these tests one at a time, where we get a failing test, so that's the red, and then we have green, the simplest possible implementation to make it pass. Sometimes it's a matter of interpretation there, but I really encouraged you, and I really tried to stick with myself, to write the simplest code, not making assumptions about future cases, but writing tests for those future cases to make sure that your code is thoroughly covered by tests. That's going to allow you to make improvements in the future, and actually allowed us to make our refactorings now as well. We could change things around, move variables around, extract them out, and rearrange that code in a way that maybe you don't have confidence to do in your production code that's not covered by tests. So we had our red step to write a test and watch it fail, our green step to write the simplest code that could make it pass, and then our refactoring step, where if we found duplication or complexity or a better way to express it, we could do any of this refactoring that we wanted to do to improve our production code. Another thing that I encouraged us to do was to not refactor as soon as you can, especially when you have these upcoming tests coming up. But instead to give it a little time to see, is the pattern I think is going to happen in my head still going to hold? If it does hold, go ahead and do the refactoring like we did by extracting out these variables that I think makes it easier to follow. And that reminds me of one more variable we can do in the last second here is silence. We could pull out an is silence variable. Maybe that's overly premature, but that feels like a nice stopping point. We do that refactoring, we rerun, and the tests still pass. So this kind of refactoring, the original definition of the word refactoring is you're making a change to your production code that does not change its externally visible behavior. So if a test starts failing that was not failing before, that's not refactoring. If a test was failing and now is passing, that's not refactoring. The code should function identically before and after a refactoring. You've just improved the arrangement of it to allow for flexibility or allow for future change or other benefits. So that was Exercism. Thank y'all so much for joining in. The folks who joined in live on the stream, it was great to have company here. And this recording will be pushed up so others can check it out in the future as well. And yeah, again, I hope we can fit it in. I hope it was fun. I hope you learned something about test-driven development or testing or JavaScript or about Exercism. I hope you're motivated to go through and check out all the different language tracks that are there. Whether you want to practice your testing or learn a new language, it's a great place to go and have something motivating. You don't have to build a huge project just to get to try out Elixir or Rust or whatever. So, well, thank you all so much for joining in. I'm hoping to do it again sometime soon. Please let me know in the chat or contact me some other way if you want to get in touch. You can see actually on my profile page here that I listed, I have my Twitter account here, Coding It Wrong. So you can reach me there. I'm on Twitter almost all the time, very reachable there as well. You can also go to my website if you want to check out my blog for stuff I've written about testing and agile development and things like that. You can check it out at codingitwrong.com. And hopefully back again soon on Twitch. So thank y'all so much. Kesk, I see you in the chat. You said thanks. You are very welcome. Glad you could be here. And thanks so much, everyone. Have a good evening. If you're in the U.S., have a great Thanksgiving, and please be safe. And hopefully we'll catch y'all again soon. Take it easy. All right, let's go to the slide. All right, see ya.